So hi guys, today's topic is about CPU scheduling in operating system. CPU scheduling is the process of determining which process is in the ready queue is assigned to the CPU for execution. The goal is to optimize CPU utilization, throughput and response time while minimizing waiting time and turnaround time. So it is a process of selecting a process from a ready queue and assigning it to the CPU for execution. So it will assign some process to the CPU for execution, which is in the queue. It will prevent idle time and improves multitasking capabilities in modern operating system. So introduction to CPU scheduling. So CPU scheduling is required because multiple processes complete for the CPU simultaneously. So multiple process will uh, knock the CPU for execution. So in that time, the CPU need to prioritize with which process need to be executed first. So it's very important for CPU for the scheduling. Efficient scheduling ensures that the system remains responsive, avoids process variations, and minimizes waiting time for user. So by CPU scheduling, the waiting time and the turnaround time will be minimized. So it will give the user more efficient to use the CPU. Why CPU scheduling is important? So CPU scheduling is important to maximize the CPU utilization. The CPU can be utilized in more efficiently and minimize turnaround time and waiting time. The turnaround time, which is in the process, have different turnaround time and waiting time. These can be minimized. Ensure fairness among processes. So the fairness of the process can be ensured by the CPU scheduling. Optimize response time in interactive systems. So it will give the response time in interactive systems while processing. Improve system throughput by executing more processes per unit time. So it will improve the system throughput by executing more process per unit time. Types of CPU scheduling. So there are three types of primary types of CPU scheduling. First, long-term scheduling, short-term scheduling, and medium-term scheduling. So we can see by one. So first, long-term scheduling. So the long-term scheduling decides which processes are admitted into the system for execution. So it will tells which process are can be admitted to the system for the execution. The short-term scheduling selects a process for the ready queue for execution. It will select the process from the ready queue. So which will the process will be in queue, which will implement in last in first out process for the ready queue for execution. Next, medium term scheduling handles swapping processes in and out of the memory for better executions. Next, CPU scheduler and dispatcher. The CPU scheduler determines which process gets CPU next using scheduling algorithms. The CPU scheduler will get the CPU time next, and there are more algorithms for the CPU scheduling. For example, first come first serve, round robin, then shortest job first, etc. These are the jobs for the CPU scheduler. Next, the dispatcher. The dispatcher is responsible for the context switching, switching the CPU to user mode and jumping to the current location in the process for execution. So it is user to switch the CPU to the user mode, which will jump to the current location in process for executions. So CPU scheduling criteria. CPU scheduling performance is evaluated using throughput, turnaround time, waiting time, and response time. First, throughput. The throughput is refers to the number of processes executed per second. The turnaround time. Total time taken from process submission to completion. Waiting time refers to the time spent in the ready queue waiting for CPU execution. Response time. Time taken from request submission to the first response. Next. Types of CPU scheduling. There are different types of CPU scheduling and different advantages and trade-offs. The common scheduling algorithms include first come first served FCFS. Next, shortest job first SJN or SJF. Next, priority scheduling, round robin, multi-level queue scheduling, multi-level feedback queue scheduling. First, first come, first serve, which is commonly called as FCFS. So from the name itself, we can come to know that the process which come first will be served first. So the process are executed in the order they arrive. So it is simple and easy to implement. Disadvantage can lead to the Conway effect, where a long process delays all others. So if a process which come first, which has very large burst time, then the the process which came the later will be uh, like affected by the process which have already came, and so the burst time can be differ, but the process which came first will be served first. Next, shortest job next. The shortest job next, from the word shortest job next itself, we can came to know that the process which has the very less burst time will be served first. So here the differentiation. The process with the shortest execution time is selected first. So it reduces average waiting time. Disadvantages may cause starvation for longer process if shortest process keep arriving. So the for example, there are four processes, namely P1, P2, P3, P4, which has the burst time respectively like 10, 5, and 4 and 3. The P4 will execute first, which has very less burst time. So afterwards, the P2, which has the 4 burst time, will execute it next. Then the P3, which has the least burst time, then the other, with and lastly the P1 will be executed. So in this way, the shortest job next will be executed. Next, priority scheduling. The priority scheduling, each process is assigned to a priority, higher priority process executed first. So in this scheduling, the priority are already given with the burst time. So by the priority order, the process will be executed. Types. There are two types in priority. Primitive. Primitive can interrupt a running process, and non-primitive issues starvation where low priority process may never execute. Next, round robin. Round robin, each process get a fixed time quantum. So after giving the process and the burst time, we need to give the quantum time for the round robin. So the definition, each process gets a fixed time quantum. Example 10 milliseconds. For example, I have given the 10 milliseconds. Before moving to the next, fair for all processes, ensure responses. Trade-off, more context switching can reduce efficiency. So if a quantum is like 1 milliseconds, it will reduce the efficiency of the process, where it need to switch one by one after 1 millisecond. So the efficiency of the process can be reduced by this process round robin. Next, multi-level queue scheduling. The multi-level queue scheduling definition. Processes are divided into queues based on priority. Example, system, interactive, background. Higher priority queues execute first. Example, real-time process, which is BAS processes. The processes are divided into a queue, so based on the priority. So here also the priority will be given along with the process and the burst time, like a priority queue. So multiple queues are scheduled in this way. Next, multiple level feedback queue. Multi-level feedback queue scheduling. So its definition is like it's similar to multi-level queue but allows process to move between queues. Prevents traviation by dynamically adjusting priority. So it is used in modern ways like Relax. So its definition is like similar to the model multi-level queue. It's but it's very its main differentiation is like the process can also move in between the queues, which is not in the multi-level queue. Next, Comparison scheduling algorithms. A comparison of different scheduling algorithms is based on the comparison can be based on the efficiency which the algorithm will produce and the fairness, the throughput, the response time and the complexity of the algorithms, schedule algorithms. Next, preemptive versus non-preemptive scheduling. Preemptive versus non-preemptive schedule. Preemptive can interrupt running processes. Example round robin periodic scheduling. As I have already said, round robin efficiency can be decreased by interrupting many processes at a time. So non-preemptive. A running process cannot be interrupted until completion. Like for example FCFS, SJ. So these are the examples for preemptive and non-preemptive scheduling. Next, context switching. The process of switching from one process to another. The CPU saves the state of the old process and load the new one. So the switching is nothing but the switching of one process to the another. The CPU scheduling in real world OS. The CPU scheduling in real world OS like Windows use a priority based scheduling system. The Windows will prioritize the process which we need to be done. Next, Linux use the complexity fair scheduler CFS. macOS use a multi-level queue feedback queue scheduling as we have already seen. Next, case study. Linux uses CFCs ensuring fairness among processes. Next, uses a red black tree for efficient scheduling decisions. Dynamically adjust process execution time based on priority. Challenges in CPU scheduling. The challenges like starvation, overhead, fairness, real-time scheduling. The starvation, some processes may never execute. Overhead, too much context switching reduces efficiency. Fairness, ensuring all processes get fair CPU time. Real-time scheduling, ensuring strict timing constraints in critical applications. Future trends in CPU scheduling. The future trends are like a AI-driven scheduling, machine learning to predict and optimize scheduling. The machine itself can predict and optimize the scheduling. Next, cloud-based scheduling, distributing workloads efficiency across cloud servers. Quantum computing, exploring new scheduling paradigm with quantum processors. So, conclusion: CPU scheduling plays a critical role in modern computing. Different scheduling algorithms are optimized for different workloads. Future innovations will continue to refine CPU scheduling for efficiency and fairness. So, thank you for watching this.